Point 3, string matching problem. After we get a basic theory about brute force method, now we want to solve a very commonly used problem, string matching problem. Yeah. All right, so let's look at our first goal in this problem, mathematical representation. So in this problem, we need to find a good mathematical representation. So that is also important. Yeah. Think about if you have some very bad mathematical representation, so what is the possible consequence? The possible consequence is it may not be very convenient to apply some special tool, math tools, to solve the problem if your representation is very bad. Then your thinking may not be that smooth. It will impact your thinking. Yeah. All right. Yeah. So let us look at our problem first. String matching. String matching. Yeah. Description. Given a string of n characters, we call it text. Yeah. The data, we want to do the process on it. Yeah. Given block of data. Yeah. And a string of m characters, pattern, we call it pattern. Yeah. With m less than or equal to n. Smaller the pattern, usually very small. Yeah. The block of text n very large. Yeah. But here we only require m less than or equal to n. Yeah. Then we do comparisons. Our goal, find a substring of the text that matches the pattern. Substring. Yeah. So anywhere in the text, that particular substring equals the given pattern string. Yeah. So that's simple. So you can see this problem, when we do the search, when we, frequently, we need to run the search operation through some text, right? So this problem, this computing problem needs to be solved in that situation. Yeah. All right. So yeah. Right. So what do we mean find the location, right? Here we need to clarify what's the meaning find its location. Right? Yeah. Because the description in the question not that clear. So we need to clarify that part. That is, find the index I of the leftmost character of that substring. Leftmost character of, what's that? Find a substring. So this substring. Yeah. That's the exact meaning. Yeah. All right. Now we look at the first solution. The first solution, straightforward thinking, the brute force method. Yeah. But there is another advanced solution in our textbook. Yeah. It is very complicated. Yeah. We may not have a chance to do it. Yeah. If you are interested after you learn this brute force method, if you are interested, you can find it in our textbook. Extremely complicated. Yeah, it is very likely you will get lost. You will get lost. Yeah. All right. Mathematical representation. First, how do we represent the text part, right? Yeah. So our goal, we apply mathematical tools. We want to manipulate the data. So we want some convenient representation for our math tools. Yeah. All right. The text part, very simple. We use a sequence of symbols. Yeah. Character T with subscripts from 0 through n-1. Why n-1? The total number of characters, n. Pattern, P sequence. Yeah. A sequence of characters from, we use P and the subscripts from 0 through n-1. Yeah. All right. The requirement, we need to represent the requirement of this problem. Yeah. Find the location I such that the subscript location I such that Ti equals P0. Yeah. I equals P0. Yeah. And so on. Yeah. You know, Ti plus 1 equals P1 and so on. Ti plus j equals Pj. The general expression. Yeah. Then the last one, Ti plus n-1 equals Pn-1. Yeah. So here you can see, although the mathematical representation is very simple, but, so you can see, it is important. Yeah. We can use this representation for our discussion. Otherwise, we may not be able to do some very clean discussion. So if your representation is very messy, you know, it is very hard to organize your thoughts. Your thought will be very messy. Yeah. All right. Next, strategy. To solve this problem, although it is pretty simple, but we need to take some useful strategy here. Here I want to talk about this guess and verify strategy. Guess and verify. You guess some possible result. Yeah, based on your understanding, make a good guess. Based on your, experience, analysis, you make a good guess. Then you need to verify if your guess is correct. Yeah. So that approach, yeah, very simple, but in our scientific research, we use this approach a lot. Scientific research, we use guess and verify frequently. Yeah. All right. So here, the thinking. So let's do the analysis. Question: can we exhaust all such M strings? First, we introduce this terminology, M substring. We know, first, it's a substring. Second, number of characters in this substring, M characters. Yeah, so that's the simple meaning. Yeah. Oh, just a minute. Exhaust, right here. Can we exhaust all such M string? Yeah. First, we know we can, right? Yeah, we can. Yeah, from beginning to end, we can. But here I want to emphasize, when you see this exhaust word, then it corresponds to brute force. Brute force method. Yeah. Yeah. Because usually, when we use an advanced algorithm, we don't want to exhaust all the possible cases. We want to eliminate as many cases as possible. We only want to focus on useful cases. Some cases useless, we can skip. Yeah. But how to detect? So what case is useful, what case is not useful? We rely on an advanced idea to do that. So that's another way to understand brute force method and an advanced method. Yeah. Brute force method You do not apply any special technique to eliminate special cases. Advanced method, you want to apply some advanced technique to eliminate a large number of cases. So that is the essence of the view for the difference of these two types of methods. Yeah. All right, next. All right. Okay, number one, every time we extract an M substring from the text with consecutive characters. Yeah. Consecutive characters, because when we define substring, what is substring, right? A block of text, small block of text containing consecutive characters. That's the meaning of a substring. You cannot jump, right? You cannot jump. That's what our understanding of substring. Yeah. Number two, compare it with the pattern for a possible match. Yeah. One by one, comparison. Here, we do the comparison, straightforward comparison like this. Yeah. That's the step two. Then, question, how many such M substrings? How many? Yeah. It's a simple question, but can you get the correct answer quickly? Yeah. Here, I want to show you guess and verify strategy. For this simple question, we can use that. Yeah. How many such M substrings? Yeah. The first answer, you can make a guess. Make the closest possible guess you can. Yeah. We know the whole block of text, the length, and then each pattern, small sequence of characters, M, right? So the number of M strings you can find in that text. The closest possible guess, I think most of you probably, is N minus M. The most likely answer, N minus M. Yeah. Then the question is this correct? Is this guess correct? So we need to verify it. Yeah. But how to verify? The question, how to verify? Yeah. Let us use a special case to give us the answer. Special case. Yeah. So what is the simplest special case you can get? Yeah. When M equals N, that's the simplest case, right? But when M equals M, your guess becomes 0. N minus M is 0. No comparison, no substring in the given text. But we know where the text length and the pattern length the same, we can find at least one. We can find one substring, right? One M substring, right? Yeah. The whole text. That's the 1M substring. So solution should be 1, not 0, right? Yeah. Then you fix it because you find a difference. The difference is 1, but you can fix the difference easily. Add 1 to your guess. You just add 1 to your guess. Your guess is 1 short to the correct answer. All right? So the correct answer is N minus M plus 1. How about that? Guess and verify strategy. All right. Next, implementation details. Now let us do the implementation. Yeah. When we do implementation, we work on the given array. All right. So we start from the first M substring. Yeah. So that it's very easy. The starting location I equals 0. Right? The starting location I equals 0. Then we want to find the location of the last M substring, right? Yeah. But the question is, how do we know the subscript of for the corresponds to the last M substring, right? Yeah. Leftmost subscript. Yeah. How do we find the leftmost subscript of the last M substring? Is there any good way to get it, right? Here I want to introduce an important idea called invariant idea. Invariant idea. Yeah. So what's that? Here, look at a special property in this problem. The difference of two n subscripts of each subscript. Look at that. Can we examine this? If we examine this, the length, right? Each substring, the length is fixed. When you move the substring in the text, the length of the substring always fixed. That means the difference is always fixed, right? When you move anywhere, your substring in the text always fixed. How about that? Then we call that invariant. So that is the invariant quantity we want to consider. Yeah. All right. So the first one, that invariant quantity, n minus 1. N minus 1. The last subscript, n minus 1, the first one, 0. The last one minus the first one, n minus 1. Then, for the last substring, n minus 1 minus x. But because we don't know this x, the question mark, x. So we make it x. So we want to find the value of x. Yeah. Now you set up this simple equation. N minus 1 should equal to n minus 1 minus x. So you solve it for x, so you get x equals n minus m. How about that? Then our answer, little I, the location, subscript for the leftmost subscript of the last m string, n minus m. How about that? Okay? All right. Then our final conclusion. Yeah. Best case efficiency, you only get a 1. You only need to compare the first m substring, right? So the number of character comparison m. Yeah. Because for each m substring, you need to do all m character comparisons, right? So that's m. Yeah. Then the worst case, you need to go through all the possible m substring. So the number of character comparisons n times the total number of m substring, that is m minus m plus 1. All right. Then average case efficiency, you take the average. Yep, because that's the linear change, right? From the best to the worst, the change increasing 1, 2, 3, linear change. Yeah, so that is the average. All right, so we finish our part D.3, and also we finish our part D.